Dear friends, welcome again into yet another session of mathematics into my YouTube channel, Maths with Mukesh Raj. And in the previous session, we have already started with the topic of trigonometry, and we will continue with this, taking ahead one step by solving few problems based on the concepts that we have studied in the previous class, based on the trigonometric ratios, trigonometric identities. And today we are going to see that in this session, today we will be seeing that how these trigonometric ratios are supposed to be implemented with respect to a given right angled triangle. In this question, as you can see on the screen, there is a question: sine A is equal to 8 upon 17. Then in such a situation, for a given angle in a right angled triangle, for a given angle A, we have to find out the other trigonometric ratios, which includes all the trigonometric ratios except sine A, because sine A is already given into the question. So let's not waste time and directly switch on to the solution of this problem. But before moving ahead with the solution, I would request all my dear friends to please do not forget to like, share and subscribe my channel. If these videos which are being made by me worth to you in your studies or with respect to examination, please don't forget to like, share and subscribe. If you have subscribed from one device, it's my humble request that please do subscribe from multiple devices, because these subscriptions and your comments, valuable comments, share, really motivates me a lot to make such interesting and new videos for you. So friends, let's see. From the question, we can deduce and try to solve this question by the help of a diagram. Let us first understand this. Let's assume that this is the side, this is the angle A, this is the angle B, and we know that this angle is 90° at the angle B, and obviously this is going to be angle C. For an instance, for the given convention of the sine, we know that sine can be represented as sine of any angle A or B. For any given angle A, we can obviously denote it in the form of opposite by the hypotenuse in its ratio, opposite upon hypotenuse. And then from the given triangle which we have already drawn to make you understand and accept this concept in a proper way, for this angle we have been given sine A. For this angle, obviously the opposite is going to be BC for the angle, and the hypotenuse is going to be the value at AC. Now from this equation, from this relationship, we can write the values for sine A equal to 8 upon 17 as, let's say this is the AC, so I am writing here as 17, and I'm using a constant variable K. This will be applied to all the given parameters. Sorry. Now see, for this BC, AC already we have taken as, and BC will be like 8K. Now keeping into this mind, we will be solving for the value of AB. Now how can we find out the value of AB? By using Pythagoras theorem. Pythagoras theorem. I'm sorry. 8K is here. Now see, Pythagoras theorem. Pythagoras theorem. This Pythagoras theorem will be applied only in the case of a right angled triangle, and this right angled triangle, we are having ABC as right angle at B. So let us see, we will directly use this Pythagoras theorem to calculate the value of AB, as AB square will be equal to AC square minus BC square. Now putting the values, we know that AC square from the equation is 17K square. I'm using this so that finally it will get cancelled out and we will be left with the actual value in the numerical form. That is why 8k square. And on solving this, we will get 289k square up minus 64k square. And then on solving this, we will be getting a value equal to 225k square. See, then we will reach to the conclusion that with the value of AB as 15k. Now, since we have calculated all the values, two of the values are already given from the which we have been deduced from the sine value of A, and then we have calculated the value of AB as 15k. Now, putting this value into this figure, try to get this figure picturized into your mind, and then we will solve for other trigonometric ratios. Now, what are the other trigonometric ratios that we are looking for? The other trigonometric ratios are, the first one is cos of angle A, and we have seen that the cos of angle A will be equal to adjacent side upon hypotenuse. Okay, from this figure, adjacent side is AB and hypotenuse is AC. So I can write it like this: AB upon AC. Now, putting this value of AB as 15k upon 17k, this k will get cancelled out and we will be left with the value of 15 upon 17. So this is the value for cos A. Similarly, we can find out sine has already been given, cos we have found out. Now we can find out the value of tan of angle A. Tan of angle A, the tan of angle A will be equal to, we can find it out by the given two trigonometric ratios that we have already calculated. The sine is given to us and cos we have given, and we have seen in the previous session that the value of tan can be represented in the form of trigonometric ratios as sine of A upon cos of A, cos of angle A. Now we know that sine of A is equal to 8 upon 17. This will be divided by the cos value, that is 15 upon 17. So on changing this, on taking the decimal division converted to multiplication, we can write like this: 8 upon 17 multiplied by 17 upon 15. And then finally this 17 will get cancelled and we will be left with the value of 8 upon 15. So this is the value for tan of angle A. Similarly, we will be finding for the value of sec A, sec of angular value A. Sec A is nothing but it is inverse of cos A. Now we have seen the value of cos A is 15 upon 17. So taking the inverse, that is 1 upon reciprocal of 1 upon 15 by 17. So we will be left with the value of 17 upon 15. Then the next trigonometric ratio is cosec A. Cosec A is nothing but it is the inverse of sine of A. This inverse of sine of A, it will be equal to, sine value is equal to 1 upon 8 upon 17. Now this value can be written as 17 upon 8. And finally, we need to find out the value for cot A. Cot A is nothing but the inverse of tan. We can either use it as inverse of tan, or we can take the value of cos of A upon sine of A. Sine of A. Either of these two relationship can be used to find out the cot. We have found out the value of tan, that is 8 upon 15. So we will take the inverse of tan, 1 upon 8 upon 15, 1 upon 8 upon 15, and then we will be left with the value of cot A equal to 15 upon 8. So this is how we can find out the entire trigonometric ratios if any one of the trigonometric ratios is given with respect to any of the given triangle. For that, what we can do here is we will be applying the trigonometric ratios with the corresponding sides, and then we will find out the remaining side of the triangle, right angle triangle, and then this can be found out by applying the Pythagoras theorem, and then finally we will be reaching to the goal of finding out all the given trigonometric ratios. So friends, thank you for watching the video. This is all in today's session. Hope to see you very soon into yet another session, yet another video. Thank you very much. Take care and best of luck.